Hi, I'm Dean Bushmiller, and we're going to talk about cloud computing architecture principles and practices. This is the second part that talks mostly about how to get things done rather than the governance, which was the previous part here. If you want the mind map, quizzers, or the full video because you don't have access to it, you can go to expandingsecurity.com. So let's get started. So what are we really doing here? Well, we have to talk about before the cloud and then after the cloud. And we're talking about the infrastructure. We're not doing any programming here. But before the cloud, what we would do is we would look at the existing environment, the business needs, and the mission, and then we'd go out and buy equipment. We buy software licenses, all that kind of stuff. And that's great. And we would start to talk about doing enterprise architecture at this point, because we don't just want to keep on buying servers because they'll breed like rabbits. You'll have too many of them. So what we do is at a certain point, and I think this happens somewhere around 500 servers, maybe it's 100 servers, depending on how homogeneous they actually are. But at a high level, we're looking at adopting, developing, and coordinating a strategy for our computing architecture, okay? And that system's got to meet the customer business needs and requirements, and those requirements go on into the future. And then how do we adopt them and how do we coordinate the new material that's coming in? So we create a plan that allows for change and growth of the organization. We have to figure out how those components and capabilities necessary to build the cloud are connected in order to deliver the online platform. So it's not stuff that we have right here. I can't go, okay, I want to take this server and I want to take this server and I want to connect them together. How do I do that? Oh, I need networking cables and those kinds of things. We have to do it differently. We have to think about it in a different way. So then we start talking about engineering, which is technically solving the business problem. Management environments are based upon like some sort of security policy, and we're deploying and debugging cloud service provider tools for our mission, okay? And we're doing that using cloud software. We're designing cloud software. We're taking an interface that a vendor gives us like a Google or an AWS, and we're going, oh, we're going to use these components this way. Today, if you go to look for something like audit information within the AWS infrastructure, I think there are 5 different major tools that you can use that will support your auditing infrastructure, and they're used in different ways depending upon what your business looks like. That's an engineering capability that's out there. But what we need to do when we're dealing with the cloud is we need to shift the way that we are thinking. So I'll ask you, hey, what's your server name? No, your servers don't need names. I mean, they need some random strings of characters, but you don't do it like that anymore. Think about it like a farmer. Your farmers don't name their plants, so they don't name their cattle. I mean, that would be a waste of time. I mean, it's really harsh, but it's true. We focus in on the construct of cattle, not pets, when we're dealing with servers. So you are now a server farmer, not a server farm, but a server farmer. You're going to lose your whole farm if you spend too much time on one server over here. Oh, let me coddle my favorite server. No, kill it. Terminate it, move on and start over again, especially in the cloud. That's how you shift things. I realize in the enterprise, because we have a sunk cost on purchasing this unit of compute right here, that we really want to go ahead and take care of it because we want it to last for the entire time. But we no longer have this. This is just, this is a click operation. So we have to shift that mentality right away. What do the best cloud architects look like, and how do they set themselves up? Well, they solve service problems by utilizing the cloud services provider techniques that are available from that cloud service provider. They don't use enterprise techniques anymore, and that's really what we're going to discuss today. Now, let's talk about what we can do alone for a second. So we could start with virtualized servers, those lifetimes where this thing, oh, this is my favorite pet server, I love it. Oh, I've had it for no, we don't do that. Now in virtualization, the lifetime is either in weeks or in months. And so what we do is we start moving to short-term services on a virtualized server sitting behind probably like a load balancer, right? And so we can turn those servers off depending on what rack they're in and how they're working. We turn them on and off as we need them. Now, the lifetimes here are based upon bursts of demand. So in theory, what we could do is we could have a rack of virtualization and have, 1,000 CPUs in that rack. And we can say at these business times, we're going to dedicate all those CPUs to end of month closing for accounting and inventory. And so what we'll do is we'll spread that out and make it so that those things act really fast. After the end of month closing, and once we've closed the books out, we can reduce that overall utilization for that and then put it on side of the research and development side or whatever else is popping up at that point. Now, we've now reduced the server to a stripped down single service for one step in a workflow. It just has one function. It's a DNS server. It used to be that when I had these servers right here and I had bigger ones, I would go, oh, you're my DNS server. Oh, you're my web server. Oh, you do all the, we don't do that anymore. This, especially when I go ahead and I hold up my little tiny Raspberry Pi, this usually only has one function. In my lab, I have one of these that runs my video controller. And that's all it does. And the rest of the time, it doesn't do anything else. I could theoretically, I build that into my workflow, but I could theoretically turn that thing off anytime that I'm not recording video. Now our lifetime has been reduced to either seconds or minutes for that particular function. Sometimes it's a little bit longer, but we're reducing down, and that's the idea that I want you to get. So let's say we need a cloud service provider. So we're going from what we had before that we could do alone. Now we've got to switch over to cloud service provider because of the tools that they're going to offer us. There's no more server in theory. I mean, we can go get servers from them, but we could get to a level where there's no server whatsoever. And this is based upon like single functions or single transactions. Now the lifetime of the server that we thought of before is now in milliseconds. When a DNS request comes in, we spin up the DNS. It's not really a server at that point. It's a cloud service that says, here's that transaction. And I now pay, like for DNS request, I now pay $5 for 1 million transactions. If it's a really, really big service, I may pay $1 for that transaction because it's got a whole bunch of moving parts. But now we're stripping things down into very, very limited lifetime in milliseconds. So there is no server anymore. Now, we're starting to talk about cloud native and transaction as a service. I don't like using transaction as a service, but it's something that you want to hold in your brain. So this is what we're going to pull apart and talk about in the rest of this video.